All right, so as Kim said, my name is Robert Sessick. I'm a software engineer on the Chrome team. And today I'm going to be giving a talk called Zero to App, Bootstrapping in AngularJS, which is basically just going to take you through the process of writing a small but functional app in AngularJS. So before I begin, I'd like a show of hands. Who's never really written something in Angular, but maybe have read the documentation? Okay. How about those of you who've probably written an app but are still sort of sinking your teeth into AngularJS? Okay, yeah, that's what I thought. And how many people are experts? Just know it all. Cool. You may be a little bored. Sorry. All right. So what we're building, we are going to build a simple search engine for a database that the USDA provides of about 8,500 food items and their nutritional information. And for this purpose, we're just going to assume the existence of a database backend. And I will demo it for you right now. Okay. So this is the home page. It may look a little familiar. So let's Google or Foodle for some coho salmon. And I can't see what I'm doing. All right, so if we look at this fish product right here, we have a selector for the portion size of food. In this case, it's in fillets, half a fillet, and it gives you all the nutrient information about fish and then some additional details on the side. And if you change the portion size to 2 fillets, all of the nutritional information should update in real time. So that's basically what we're building with AngularJS today. All right, but before we begin, a few notes about the backend. I wrote in Go, and it's about 900 lines of code. Your government provides you this data in a ASCII dump format from a Microsoft Access database, which isn't really the friendliest format. So the server loads it in on launch into memory and creates a binary search tree for the search terms. And then it's also our front-end web server for the AngularJS files. So it'll serve the static content that our app is actually going to be written in. And the backend exposes 4 API endpoints. The first is pretty self-explanatory. It'll search given some terms and return an array of sorted results. The second one will return the complete food object. The food objects are rather large. They'll let nutrient information, and so the search results page only returns a subset of that object. Then there's the last 2 endpoints are for relational data to a food object. So the food group names and then information about the nutrients like the unit that it's measured in and the name of the unit are both related based on a numeric key. And this is where we're going to start. Just a basic index.html with HTML5 boilerplate. I've pulled in Twitter's Bootstrap grid. And then there's some basic CSS that I wrote to get the home page with a search field and a search button. So to turn this simple index.html file into an Angular app, we begin by adding a directive called ng-app to the HTML tag. This basically tells Angular that this is going to be an Angular app, and then it should compile and link this HTML page as an Angular template. Those are 2 phases of Angular's execution. I'm not going to go into them here, and you don't really need to understand them to write an Angular app, but you can read about it online. After you do this, we're going to create a controller, and ng-controller is used to do this, and it takes a name of a JavaScript function or object to instantiate when it encounters this tag. ng-controller creates a scope, and a scope is an Angular term for something that encloses over DOM elements, and it manages the relationship between the DOM, i.e. your HTML, and your JavaScript controller. And so in Angular, you try and avoid accessing the DOM directly, and you use scopes to sort of indirect through that, so that your HTML is just pure display, and your JavaScript is pure business logic. And then I'm also wrapping the input fields in a form tag that has an ng-submit handler on it, and it'll call a search method on our search controller when either the user presses enter in the search field or presses the search button. And then this is our controllers.js file. It's pretty simple at the moment. We are defining a new JavaScript object via a function. So this constructor is going to take the scope, which in AngularJS is the equivalent of the this object. $scope is provided for you by Angular when you use ng-controller. And on our scope, we are defining a search method. And this right now is pretty uninteresting. It's just logging the word search. And so to get the value of the query field that the users entered, we use a directive called ngModel. And this takes a property name to assign on your search controller object. And this establishes a bidirectional binding between AngularJS and your view or HTML. So when the user presses a key in this field, it'll automatically be sent to your controller. And conversely, if you programmatically change this property on your controller, it will be pushed to your view automatically. Because of that, we are going to set the query field to be an empty string by default. Otherwise, the word undefined would show up in the search field on load. And we're now going to just log the query when the user enters the term. And so now we actually need to connect to the backend because just logging the query string is not really the goal. And to do that, we need an AJAX object. And so we specify that we need $HTTP in this constructor function for our controller. And AngularJS uses a system called dependency injection to provide services to your controllers and other functions. And dependency injection basically is, instead of creating an AJAX object for use, you just say, AngularJS, I need this in this function, and it will provide it for you automatically. And we're just going to initialize an empty array for the search results that we're then going to store our search results from the backend in. And we're going to change the search action to, instead of logging, to issue an HTTP GET. And this is going to go to the backend. And we are going to use a configuration object for this HTTP request. Using the params key, we're going to specify a dictionary of parameters, in this case Q, which is the search terms. And we're doing this so that AngularJS will automatically encode URI component or escape the query string that we're sending to it. So HTTP GET is a method on the HTTP service, and it's going to return a HTTP promise object. And that has two methods. One is success, which we're going to use here, and one is error, which we're not going to handle errors at the moment. We'll do that later in the presentation. But in success, we have a callback function which takes up to 4 arguments. We're only using the first here, which is the actual body of the HTTP response. And this is JSON. It's been parsed for us and deserialized. And so we're just going to assign the result array into the results on our scope. And that's pretty much it for the JavaScript of this. We're going to update our template to have a list of search results. So we're inserting it below the actual field. And this is, we're going to dissect this a little bit. So we're using this ngRepeat tag, or directive, sorry. And this takes a for loop-like expression. So it's going to iterate over the collection of results, the array of results, taking each result, and then duplicating this li template element for each result in the collection. ngRepeat also creates a new Angular scope, just like ngController did, and we'll sort of understand more about that in a minute. And then we're going to use the string interpolation provided by AngularJS to automatically XSS escape whatever came from the backend, meaning it's going to encode HTML entities so that they don't run on the page. And we now have a list of results. These aren't linked yet, though, to anything. These are just a list. And now what we're going to do is just limit the list of results to 10, because the backend could return 1 result, could return 50, it could return 120. But we really want 10 results, because beyond that, it's probably not much use. So the only change we're making here is changing the ngRepeat to use a function that we're going to define on our controller rather than the collection itself. And then we're just going to write a simple JavaScript function that loops to either 10 or the end of the array and pushing results into this new temporary array. So now we have a page with 10 links, or 10 results, and we need to link these to some detail page. But before we can do that, we need to restructure our code a little bit, because in order to use Angular-based routing or link detection, we need to use a module. And so we're going to restructure the code that we have now into an Angular module. And Angular provides modules as a way to organize your code, and you also configure built-in services, which we'll see here. We're going to define new services in a module, You can also define filters and directives. We'll define a filter later. And it's also a place to namespace constants. Like if you have a production URL and a staging URL, you could define those as constants on your module and access them through that. And so to create a module, in a new file, we're going to call angular.module. And this takes a name and then a list of dependencies that this module requires. So if you have more than one module, because you're organizing your code, you're in a large project and you're organizing your code into separate modules, you list the dependencies on one module in its definition. And modules have a life cycle. The full life cycle is documented online in the developer guide. But one of the first functions that's called is config. And this is used to configure services, like the HTTP service that we were using earlier. And some services are configured using a separate object other than HTTP, and it's usually called its provider. And if you see in the Angular docs, there's little gears next to services on the list. That's the documentation for that services provider. And so a provider is just something that is used to configure an object. Currently, we're not going to do that. We're just going to log. And then you specify which module you want Angular to sort of instantiate first by using the ng app and giving it the name of the module that you've just defined. So as I said, you need to use the config function on a module to configure a service. In this case, we're going to use the route provider object to configure the routing service in Angular. And that's pretty straightforward. We just say when the URL is /search, we're going to include this HTML fragment partial into the page. So rather than having the search results displayed inline, we're now going to move those out into a smaller HTML fragment file that's just going to be the list of search results. And when the user goes to this page, that will be injected onto the page. And so we do that using an ngView directive, which we're going to see here. But we're going to create, before we do that, a new controller called the home controller, which is just going to be a subset of the logic of the old search controller that we saw. And this is just going to be responsible for managing the action on the search field and the search button. Oh, and if you do have questions, by the way, please stop me and someone will come around with a microphone. And so here we're going to use the ngView directive on a div, and that's going to include underneath this, inside this div, whatever template partial we specified in the route configuration. ngView also creates a new scope, which will be important to know. And that's pretty much our new index.html, or a fragment of index.html. And we are moving the search result list, as I said, into a fragment called a partial. And we are keeping the search controller attached to this fragment. And finally, here's our JavaScript. We are using, this is the home controller here, and we're going to use this new $location service, which we haven't seen yet. But this is basically a wrapper around window.location in JavaScript. AngularJS has to wrap a lot of what happens in the JavaScript environment, such as window and location. Question?
Hello. Can you have multiple views?
No. There are different ways to do it, but general answer is no. So as I was saying, AngularJS needs to wrap everything because if a change to an object happens outside of Angular's systems, then it's not aware of it, and you'll get out of sync between Angular's idea of the world and the JavaScript execution environment. So $location provides a wrapper around window.location, and here we're just going to get the Q value from the location bar, which is the query string, and we're going to use that as the default value for the search field. So that if one user sends another user a link to the search results page, that gets populated in. And then secondly, we're going to change the search action to, rather than performing an HTTP request here, we're going to just redirect the user internally without actually reloading the page to the search results. And so we're just changing the Q value in the query string, and then we're changing the path. And again, this isn't actually going to cause a page refresh. This is just going to notify Angular's routing system to change its idea of the current path, and then it will execute again whatever new template partial needs to be injected. And then finally, the search controller has changed a little bit. We are no longer executing an HTTP request in response to a search action. Instead, we're just doing it in the constructor. So when ng controller encounters the search controller, it will instantiate this, and it's going to use scope inheritance, which we'll talk about next, to get the query value, and then it's going to execute the request and put the results on the page. So I just mentioned scope inheritance. So we have a structure of scopes now on our page, starting with root scope, which AngularJS creates for you via ng app. We have the home controller, which we created using ng controller. And then we have this ng view, and I said that created a new scope, and so there's now another scope underneath that, and that's actually responsible for the view that's being injected. And on the search result page, that would be the search controller, which itself is host to an ng repeat, and that is creating a new scope for each item in the collection that's being repeated over. There's more details about scopes, such as they're hierarchical, and you can access that chain in JavaScript via $scope.$parent. You don't often need to do this, but you do sometimes. And there's also an event system that can broadcast down and emit up the chain of scopes. So if you have two scopes that are siblings rather than a parent-child relationship, you can use the broadcast system to send up and send back down. So as I said, scopes are inherited, so you can actually access properties of a parent scope and a child scope. There's some subtlety in this because of the way JavaScript prototype inheritance works. But for object values and array values, you can access and mutate them from a child scope. So now we need to start plumbing the detail page through. And to do that, we're going to add a new route in our config function of our module. And this route is pretty similar to the other one, except it's parameterized. So the second path element, rather than being a string literal, will be a wildcard value. And this will be stored in a variable that we can access in the route params service. And this is just a collection of all the parameters that were in the current route. And so in the detail controller that we're building here, it's pretty similar to the search results controller. We're just going to execute an HTTP request when it's instantiated to get the food object from the backend. And we're using route params to get the NDB ID, which is the identifier for the food item, using the parameter that was specified in the location bar. I've built a detail page which just contains some of the basic string properties of the food item. I highlighted it here for brevity, but you can see it there. And I've modified the search result page to actually include a link to the detail page now. So now we actually have a list of links that will take you to a detail page that will display some basic food facts. And now what we're going to do is handle an error, because the ID will be visible in the location bar. A user may muck with that a little bit, and if the backend returns an error response rather than an HTTP 200 OK, we should probably show an error message rather than just breaking. And to do that, we're using the second method that I mentioned on the result of HTTP get, which is an HTTP promise. And it's called error, and it takes another callback. And in this case, we're going to use the plain text response from the backend as an error message. And then we're going to display it inside the detail controller using a directive called ng-show. And ng-show takes an expression, and if that evaluates to Boolean true, it will show that element and all of its children. And so we're also interpolating the error message here. So this block will show if the error is present. And note that we haven't defined scope.error except for outside of this error function, because it being undefined is perfectly okay if there is no error from the back end. And then finally, the div that wraps all the information about a food has been hidden if there is an error. So if the error is present, it will hide the food information. So now we have an error page, and we have the details all in the same template. So as I mentioned, some of the data in a food object is relational, and you need another backend request to get the, for example, food group name from the food group's number. And to do that, and to format this in the presentation, we're going to use a filter. And a filter is just a way to format some data without changing the data that's actually in the controller and the model. So this is only happening at render time. And to do that, we use the module function filter, and it takes a name and then a constructor for the filter function. So we have a function that's returning another function, and the function that's being returned is the actual transformation of the data. And the arguments to the function of the second argument are services that should be injected, just like we saw with $scope and $HTTP and $location. We'll see that again on the next slide. So we're defining a new filter, and this is just to show you how filters work. We're just going to append the string food group is number blah, and the input is the food group number. So you wouldn't want to show this to a user, but it demonstrates how you'd build a simple filter. AngularJS provides filters to round numbers to a certain number of decimal places, uppercase and lowercase strings. So these are things that you wouldn't want to actually do in the controller because they only are affecting what's being shown to the user. And so the view or the template is the perfect place to do it. And you use a filter by taking your input data or your starting data and piping it through the filter name. So in this case, we're taking the food group identifier and piping it through the food group name filter, which will at some point return the actual food group name. Yes, question?
How often will the data be ran through the filter? Like, for instance, if you had a variable that was going to change, how often would it be rerun?
Every event cycle that Angular does. So just like any other interpolated value, it will be re-evaluated every time that it needs to be in terms of the JavaScript event loop.
And does the same thing go for the filtered data function that you wrote? That'll be reran every time?
Exactly. Every time that AngularJS detects that an event has happened in JavaScript, it will re-evaluate your models and controllers and re-execute anything that needs to be done.
Hi, this is just a quick question. For the filter in the future, we're planning to run through another HTTP GET request? Okay.
Yeah, we'll see that actually next. Well, we're going to build an Angular service now, which is going to execute the HTTP request, which will be, and this service will be used in our filter. So a service is defined pretty similarly to a filter. It takes the name of the service that we're defining and then the constructor function for that service. And again, the arguments to constructor functions always take the services that AngularJS should inject into the constructor. In this case, we're going to inject $HTTP like we did in our Angular controllers. And then we're going to define a basic JavaScript object. It has one data member, which is an object, and then a method on the service, which is name from ID. And so that'll take the ID number and it'll look up in the data object that it has the identifier and return the description of the food group. Otherwise, it'll return the string unknown. Again, still in the constructor of our service, we're going to execute the HTTP request to the backend. And when it comes back, we're just going to transform the array of food groups into an object keyed by the identifier. And keep in mind, this is asynchronous. So this will probably complete after we return the service. But that's perfectly okay, because it'll be assigning back into the object that we have just returned. And then to make our filter actually return the right thing, we're going to specify the food groups service that we just created as an argument to be injected into the filter function constructor. And we're just going to use it to get the name from identifier. And so now we can actually reuse this on the search results page to put the food group name next to the actual link. But backing up just for a minute, so the food group service is only created when someone needs it. So AngularJS won't actually create our service until it's requested. And then it'll instantiate it once, and services are singleton. So this food group service will be the same as any other food group service that's requested anywhere else, just like $HTTP is. So the $HTTP in our service is the same that's in our controller. They're singleton objects. Is there a question?
Hi, sorry, I just had a question about filters.
Yes.
Can you chain more than one filter together? And the second question is, do filters have to be declared or defined in the scope of a controller, or can you kind of like reuse them across controllers?
That's a good question. I actually don't know if you can change filters, chain filters. You can?
You can chain them, and you don't declare them in a controller. You declare them in a module.
Yes. We're declaring the filters on a module rather than the controller.
Well, I mean, you can have more than one module active at a time, so you could make a module that just contains filters if you wanted to. And
All right, so now we're actually ready to build the UI of the detail page that we saw at the beginning, which is the unit selector and then the automatically refreshing nutrient information. And to do that, we sort of need to understand the model object that the backend is returning. So there's a bunch of string properties, like description information and information about the refuse, like the skin of an apple is considered refuse by the USDA. And so there's two arrays, though, which have relational information. One is an array of weights, which are common household measures, like a stick of butter, a fillet of fish, 6 chips. And so that contains the amount, so like 6 chips, the description of the unit, and then its weight in grams. So the USDA has measured all of these units in grams and put it there. The second one is an array of nutrients, and that just contains a nutrient identifier, and then the amount of nutrient per 100 grams of that nutrient. And so using this formula that the USDA has provided, we can actually calculate for any portion size the amount of that given nutrient. And we'll use this in a function on our scope later. And so I've also written for us another service and and 2 more filters, which pretty much do the exact same thing as the food group name, except for the nutrient units and the nutrient name. It's not really interesting because it's almost identical to the food group service, so I've skipped it here, but I've written them. And note that the nutrient value that we're displaying here is, this is, by the way, the nutrient table that we're displaying. And the value that I've put in here is actually per 100 grams of food, and so it's not actually correct at the moment. And we'll come back and fix that in a few slides. So to create the unit selector, we're going to use something called ng options. So we have the unit selector and we have the select field. And ng options is a pretty cool directive. It can take 8 forms, the value of ng options, and here we're just using one of them. Basically what it's saying is in this orange box is some iteration over a collection. Just like for result in results, we have u in food.weights. So u is some unit in this weights collection. The white box, or the tan box, is the string value that will be displayed on the actual option element in HTML. And then the green circle u is the object that is going to be stored in the green box ng model property. So what this is doing is creating a bunch of option elements in HTML. And when the user changes it, the object that actually was iterated over to begin with is going to be put in the model specified in ng model. Not the index of the element, not the description that's being displayed to the user, but the actual object that we iterated over in the first place. And this is very powerful because it means you can then use the unit property in your controller, and it will be changed automatically when the user changes the dropdown. So if you depend some calculation on some property of unit, it'll change automatically when the user changes the select menu. So now what we're going to do is, one more thing about ng options is you need to specify the default value, otherwise it'll insert a blank element initially. And so we're just going to assign in the success callback for the HTTP request the first item of the array as the default unit. Next, we're just going to create a number field for the portion size that the user can control. And we're going to bind this to unit amount, not unit dot amount, but unit amount. And the reason why we're doing that is because if we bound to unit dot amount, whenever the user changed the number field, the actual object in the array of units would be changed because we're bound to that. And we don't want to do that because that's destructive. So if the user changed 6 to 12 in some portion size, that would actually be stored on the array of food.weights. So we want to store this in a separate property, which we're going to do here. So we're binding this to unit amount. And we're attaching a change handler to our select item. This just works like the DOM on change event. And so it'll call this function that we're defining here. And again, this will use the bidirectional binding that Angular establishes with ng model to automatically update the number in the unit field when the user changes it. Because sometimes the units that the USDA provides are not always just one, but it's like half a fillet or whatever. And so if the user changes the unit in the selector, it'll automatically update the display. And conversely, if the user changes the number field, the property will be updated. Question? So your question was write what without having to use JavaScript?
That you're actually referring to the unit amount in the view rather than doing a callback and updating the unit amount.
Yes, you could change the expression to the ng change. You could change it to unit amount equals unit dot amount in the ng change directive, but I did it in a function because what if this function grows over time and you don't want to have semicolon separated values in your ng change?
Is there a way to use the actual template variables in the attributes such that you don't end up having to go back to JavaScript to actually update?
Yeah, you can change ng change. The value of ng change could be unit amount equals unit dot amount. Is that what you're saying?
Well, I was thinking without ng change.
Oh, that I don't know. It may be possible, but I don't know. Yeah. Oh, okay. So we've now got a unit selector that will automatically change the amount field in the display. And so now this is the cool part. This is what's going to have AngularJS automatically update all of that table of nutrients automatically when the user changes either the select field, the select menu, or the input field for the portion size. And so we're just going to find one function, which is just going to run that formula that the USDA provides. It's going to take the nutrient value per 100 grams of food, and it's going to use both unit amount and unit.weight grams to calculate the result. And then all that we need to do is change the nutrient value in the table to be run through this function. And then we're going to use the rounding filter that Angular provides by default to round it to 2 decimal places. And that's all there is to it. After the user now changes the number or changes the select field, everything on the page will update automatically in the blink of an eye. This, I think, is pretty cool. I think doing this with jQuery or anything else would be a lot of non-trivial work, and we've done it in 4 lines of code. The last thing that we should do is display the total weight for the food item in grams. To do that, we're just going to do some simple multiplication and division. The only caveat here is that I think it's run off the page and you can't see it, but we're just calling this function in our template as it's interpolated. But because this will execute prior to the HTTP response coming back, we need to protect against unit being null because we initialize that in the success function. And so we'll just return 0 if the unit is not initialized, meaning the HTTP response hasn't come back yet. And with that, the other cool thing about ng options is you can do a string concatenation in the display value. So we're going to just put parentheses around u.description and then concatenate the gram amount for that one portion in line. So now the select menu will show the item and then the gram weight for that item. And that's pretty much it. I've put all the code on GitHub, and I've tagged various commits accordingly with the step numbers in the presentation. So if you could actually check out the Git repo, and you can clone the Git repo and then check out a tag to see what the code looks like at exactly that slide. And I'm going to post the slides on my website and probably also on the AngularJS Meetup page. That's me on Twitter, and then of course the docs to AngularJS, which is the best reference for pretty much everything. All right. Thanks. Are there any other questions before?
Thanks. I got a couple quick questions.
Sure.
So I was using a directive to handle touch events to get rid of the lag you sometimes have on touch events while waiting for double click and stuff, but had some difficulty using that directive from within another directive. So let's say I had a directive called circle where I made my own custom element and wanted the touch event on that. I had difficulty having that event pass through? Is that because I didn't call emit on the event?
All right, on the JavaScript event,
Yeah.
it may be that the digest cycle didn't run in between the two. You could be emitting it and it not being processed, perhaps.
And my second question, you might not have any familiarity with this, but is it possible to dynamically create a route? I've heard that you can't
Dynamically create a what? Sorry?
a route. I've heard that you can't with core Angular, but possibly with the Angular UI router or UI states plugin. I hadn't heard whether anyone had tried to do that.
What do you mean dynamically create it?
So let's say you have a route that points to the news page, for instance, and you want the URL bar to change to the URL you're at /error if there's an error, but you don't want to create that route unless there is an error. So to create a route after the app is already bootstrapped.
I actually don't know. Sorry.
Okay, figured I'd ask.
Any other questions?
I was just going to say, I can answer that previous one. As far as I know, you can only configure routes at the start of config phase. I'm pretty sure you can, if you want to cheat that, you can kind of like have the generic route go to a callback, and then your callback function can implement all sorts of stuff that might have access to the app state. But
yeah, if you specify an otherwise on your route provider, you could maybe hook it there and sort of do detection there. You had a question? Oh, 1 second. Okay. Him first, and then you.
Services and factories and providers. What's the main difference, and when's the best scenario to use each one?
They all fundamentally create services. A factory, they're just different ways of defining it. And the provider service has different ways of creating a service. So you'd use a provider if you wanted to create a service and configure it via a provider. A factory, I believe, is a different way to use a constructor function to create a service. And then a service you just define in line. Someone have a better answer than that?
So, like, are you talking about using module.factory versus .service? So, .service, you give it a constructor, and it will use that constructor to instantiate your service. .factory, you just give it a function, and the return value of that function will be your service. And then provide is just another way of like doing it. You could just say provide, give it a string, and that's going to be like your service name, and then anything, and that is going to be what's returned as your service.
And they're all singletons?
They'll all be singletons, yes.
I have a couple of questions. So first question is, you did mention that you can use the $location service to trap window events. So what about a DOM ready, for example?
DOM ready. You shouldn't. I don't think you should be hooking DOM ready. You should just be waiting for your initial controller to be instantiated, and that will tell you that the DOM is ready.
Okay. What if I'm using AngularJS in concert with jQuery, and I have some events on the DOM ready, and I want to use that in combination?
So AngularJS is really designed to not let you interact with the DOM outside of directives.
Okay.
You can use jQuery, for example, for animations, and there's various ways to do that. I've seen some advanced stuff using a directive to animate, and then other stuff like a set window or set timeout hack. It's a hack, but you can animate that way. I don't have any direct advice using jQuery with AngularJS though. But so in your DOM, whatever you're doing in DOM ready for jQuery, you could probably move to a function in your controller, the controller that's sort of responsible for the main frame of your app.
Okay. Second question is related to the services providers and answer which you just provided. So if you have some shared functionality which is shared between multiple controllers, then would that go into a service, and what would your recommendation be?
Yeah, if you have common functionality that's sort of singleton object-like, yeah, the best place to do is to refactor that into a service, and then you can test that in the Go.js test independently of your controller logic.
Okay, got it. Cool, thank you.
You mentioned using scope.broadcast and scope.emit as a way of going up and down the hierarchy.
Yes.
I had been using root-scope.broadcast, and this seems like a better option for me, but could you talk about the difference between those two?
Sure. So, I mean, if we go back to that diagram of the scope hierarchy, if I can find it, root scope is just going to be the scope that's equivalent to ng app. And so all of the scopes that you create and the directives you use create will be a child of root scope. So if you do need to broadcast to multiple siblings that don't have common parents, you could definitely do that on root scope. And that will basically send from the top level of your app down to every single controller or anything that's watching on that event. So that's when you use sort of root scope. If you're going in a specific direction, let's say, I don't know, the search results controller had some sort of like filtering tools on it, and you wanted to go back up to the parent to sort of like add additional operators. Like, so let's say you had one of the fields in the food item is manufactured, and let's say we had a checkbox in the search results for checking if it's manufactured or not. You could then send an event up. You can emit an event up to the home controller and then adjust the query string that way. So if you have a limited sort of direction in which you're going, it'd be probably best to just use the scope that you know and do emit or broadcast. Because if you go on root scope, it's going to have to evaluate all the watchers in your application. No, but it will still have to go through, yeah, to send through everything. Yes. Is that your question? Great. You have a microphone, so
Yeah. So I have two questions. First is, what's the best practice to communicate between controllers? The second one is, let's say you have a list of items, right? So we usually do like an ng click on each items. So because in different way we can actually bind the click event to actually the parent, right? Would you suggest the first one or the second one?
So your first question first. What kind of communication are you doing between your controllers?
Like for instance, you have nested like controllers, right? So what happened outside the parent's controller? So I want to tell the child controllers what happened, and then we can do some logic inside that child controller.
You want to use what we were just talking about, which is the event system?
Yeah, which is a broadcast, right? So other than that, can we do something else?
Well, you'd probably well, there's watching. You can watch the value. Like if you have some property in your controller, you can watch it. But if you know, you could also I don't know what your exact use case is, but you could also maybe move something into a service if it's actually common functionality. You could do that if it's really truly global state. Otherwise, yeah, I would either use broadcast or watch a value. And then your second question was between ng repeat and...
So in your ng repeat, right? So we usually do like ng click on each item, right? So instead of doing that, would you prefer to do like actually find the click event to the parent and figure out which element was actually clicked?
I would bind to each element.
Because it's kind of like anti-AngularJS pattern. But I don't know.
I would just bind to each one, an ng click to each event, or to each element in the ng repeat. Unless you had like a demonstrated reason why you wouldn't want to do that, but I can't think of one. Yeah.
I have a question about broadcast as well. It's more about modal dialogues, and I had used broadcast in order to pop up a modal dialogue, and I don't know, that was the solution I came up with, but I kept thinking it wasn't really elegant, and I thought maybe of using a service, and I'm wondering, have you ever done any modal dialogues, and how do I get the values from a particular scope to appear in the modal dialogue and then passing them back?
I have not done a modal dialogue exactly for that reason.
Yeah.
You have an answer though?
you want a mic?
So, I mean, I've had arguments with people who strongly believe that you should put your modal into a directive, and then like that directive watches for some scope variable, like that tells it whether it should be showing or not. The way I prefer is I wrote a service that basically just you give it a template and it renders that template inside of a modal dialog. Not publicly that I know of, but use your imagination, I guess.
Any other questions?
Yeah. How would you optimize your app for a search engine like, say, Google?
Well, you want to minify it, obviously. And to do that, you need to change how you're injecting things. Because if you want maximum level of minification, a minifier would like rename all the local variables and the arguments to your functions. So AngularJS, if you read on the advanced topics, has a way to specify, you change a property on your controller after you've defined it that specifies the order of the services to inject, and those should match the order of the arguments. That's one thing that you do is minify it. And then that minification would really be the biggest thing, especially with full variable renaming. You have other best practice ideas, though, for...
Yeah, I guess like handling like AJAX requests with Google. So instead of rendering a static page, you've got this entirely AJAX app. How does Google handle that?
Not thought about SEO at all with Angular apps.
What is the best practice for animation with Angular?
I would probably create, depending on the animation, I'd create a directive that then uses jQuery to actually execute the animation. Yes, another question? Do we have a mic over there?
I wanted to address the gentleman's question about search engine optimization. One of the a while back, I did a presentation on search engine optimization and Angular, well, JavaScript specifically. And one of the interesting problems with search engine optimization that we were able to solve is pre-rendering the JavaScript before you send it away. And so we built this system where you used Phantom.js and a caching engine to pre-render everything, cache it on the server, and then based on the URL that was being requested, serve it up to the user. And once you do that, you can control who gets what pages. So if a spider is crawling your page, you give them a pre-cached page. After the initial page, you can then go on to using the normal Angular AJAX calls. And so there's, I forget exactly what month we did it, but you should be able to find a video of it during one of the AngularJS meetups. I also have thedigitalself.com. There's a blog post that I wrote about doing precisely that. It's all very theoretical, and we never ended up actually implementing it. But we think it's a really interesting, has some really interesting potential for general client, because more and more of us write heavy client-side apps. There's a lot of potential in using a technique like this to pre-render applications for SEO. So,
I'll follow that up too. Last meetup there was a Ruby and Angular discussion, and he talked about basically injecting the framework before the Angular data. I guess he actually didn't solve that problem now that I'm thinking about it. He just put everything but the data in the page, which wouldn't really help with SEO. Okay, I'm going to pass the mic off.
Yeah. No one's really solved this problem. It's kind of inherent it's an inherent problem with the way search engines crawl the web. I'm sure if Google wanted to, they could search through dynamic links, but it's really easy to game the system, right? It'd be really easy for me to tell you that my website is about cheeseburgers or something, right? And then when Google crawls it, the website is about something else. So it's really easy using JavaScript to game search engine results, which is why I'd imagine the search engine guys haven't been proactive in properly indexing dynamic content. But yeah, so.
I just wanted to add that Year of Moo has a very good article on the subject also.
So Airbnb recently released a tool, I forget what it's called, but it's for Backbone, but it allows you to render the page in Node.js prior to it being sent to the client. So therefore, it would really be rendering twice, which is an interesting way about going about it. It would make sure that the client actually has the data. As far as the modal question was concerned, one way of doing it is through the Angular UI plugin UI router and having it be one of the child states or child views. It would have access to the parent scope. Another way would just to temporarily put the information into a service.
Any other questions? Okay. Well, thank you.
Okay, our next speaker is an engineer that works on Google DoubleClick. His name is Mikhail Voloshin, and he's going to be talking about unit tests.
Thank you. And before I begin, I just want to give another hand to Robert over here for a fantastic slide deck. Mine are not going to be as pretty. I am here to talk to you guys about unit test pollution. Many of you probably already write unit tests with your projects. Those of you who don't, I'll be talking a little bit about why you should. For those of you who do, I'm going to be showing ways that your unit tests might be lying to you, and this lying occurs because of the order in which unit tests are run and the state that they might leave between one another. The talk will come in 3 parts. First, I will talk a little bit about what unit tests are, and this will be a basic introduction to a bit of unit test evangelism. I will then talk about various ways that unit tests can go wrong, ways that they can tell you that your code works when it doesn't, ways that they can tell you that your code doesn't work when it does. And lastly, I will show you a few techniques that you can use for detecting when your unit tests are lying to you and how to do something about it. Now, my name is Mikhail Voloshin. As Jeremy said, I work at DoubleClick on the DFA7 front end, and I'm badly in need of a haircut. Now, first, before I begin, I want to answer what might be a semi-obvious question, which is why bother talking about unit tests, in particular the Jasmine unit test framework, at an AngularJS meetup. And the bottom line is that Angular is written with the intent for unit testing from the ground up. The AngularJS team, Mishko, Vojta, Igor, and so on, they're huge fans of unit testing in general, and Jasmine in particular. And AngularJS is written with unit testing hooks specifically for the Jasmine framework, all built in. The Angular file, angularmocks.js, has Jasmine stubs, and in general, AngularJS and Jasmine just really work really well with one another. The other really big reason, the reason that the team is that the AngularJS team is so fond of unit testing is because partly out of necessity. AngularJS as a framework has a lot of places where various components that you wouldn't think would have any kind of interaction with one another do. There are many aspects of statefulness throughout AngularJS, and as such, unit tests are a great way to find where that statefulness is occurring and eliminate it. Now, first, let's talk a little bit about unit testing from a sort of a big picture point of view. Unit testing is an important part of any software development process because, quite frankly, your code doesn't always do what you think it does. And the reason that your code can do something that you, even as the programmer, don't know about, to understand why that happens, look a little bit at the software development lifecycle. Once upon a time, there was a happy programmer. She wrote a program. It worked. It was good. As you can see, there's a very simple Hello World app right here. Then one day, a manager appeared. And the product manager said to her, I want an option for hello to be in all caps. So she modifies her perfectly simple, easy program to give an option that allows for the program to output in all caps. Product manager comes up with a new idea. How about you give it an option to give a name, and then it'll say hello name. And so she added an option to do that too. Then the programmer thinks of the manager thinks of an awesome new feature. It'll cycle through different greeting messages on every call. So the programmer complies, and the program gets a little bit more complicated. Then the manager says, let's add localization. Now, at this point, the program can easily get so complicated with the addition of these new functionality units that it can quickly exhibit behaviors that the programmer herself doesn't even understand anymore. So, what can a programmer do in this situation? Well, you go through the different individual pieces of functionality, the units of functionality that the program is supposed to do. Say hello by default. Take a name optionally. Take an option to capitalize its output. Cycle through different greetings. Localize, so on and so forth. And you write unit tests for it using the Jasmine framework. Now, what Jasmine looks like, Jasmine is a framework that provides a suite of functions that basically test your code in isolation, in theory anyway. So what you end up creating are groups of functions that read like this. Your suite, say hello, should say hello. And then you've got a function right here, expect the output of the say hello function to be the string hello. You've got it should output it in all caps. And then you've got a different expectation with a different desired output, and so on and so forth. And so when you see that your unit tests all pass, you actually gain quite a few phenomenal cosmic powers. For one thing, when you've got a passing unit testing framework, you have positive proof of the program's capabilities. If somebody, such as your manager, comes along and says, does your program support capitalization, for example? Without unit testing, all you have is the claim that you implemented the logic for capitalization and it should work as far as you know. With unit testing, you have proof positive that the program does exactly what you expected it to do because you run it through a series of tests and you see that the output is what you expect. You can get a really great handle on bugs. Specifically, you can prevent regression. Here you've got, the example here is that the manager finds that the program crashes when you try to capitalize Sanskrit for good reason. Now, without unit testing, there's not much that can happen except for an argument between the developer and the manager, wherein the developer says, "I totally accounted for this. Like my logic should do this thing. Like I'm looking at it right now. I see no problems." Where the manager or QA saying, "Look, I saw it crash with my own two eyes. If you don't see problems with the logic, look harder." With unit testing, you can expressly test whether the allegedly broken functionality, and you can see it break with your own two eyes. And then it's just a matter of fixing the broken portion until your unit test passes. And then once you've got a unit test passing, you can keep that unit test as part of your regular unit testing suite, and then you can make sure that subsequent changes to your code never break this piece of logic. Collaboration is a huge benefit that you get out of unit testing. When a new developer joins your team, here we've got the manager introducing a developer that's tasked with putting banner ads on the Hello World app. The new developer looks at a giant pile of code and at first glance has no real way of seeing what exactly it does. And then when they start to add new functionality to it, no real guarantee that they won't break existing stuff. Whereas with unit testing, they can look at the code and basically treat the unit tests as living, breathing documentation of the code's capabilities. And moreover, when they start changing the code's functionality, they can make sure that they didn't break anything that the code was doing before. And lastly, by the way, typically code that's written with unit tests in mind tends to be just better code. The code written with unit tests in mind tends to be highly modularized and focused on what it should be doing rather than how it's doing it. This makes it very easy to release for cross-team collaboration or open source projects. And so with that, the whole team adopted unit testing as an integral part of the development process, and they all lived happily ever after. The end. Now, lest anyone believe that that really is the end of the story, there can be trouble in unit test land. Here we have our programmer writing an AngularJS counting service. For those of you just coming off of Robert's talk, this is this probably is a good place to pick up. What we've got here is an Angular module called demo, and we use a factory for the demo module to create a service called counter. What this counting service does is it simply has one function on it called getCount that simply returns the value of a global variable I and then increments that variable by 1. And so no matter where we are in the app, we can always tell how many times this simple counter service was called. Easy peasy. Oh, by the way, I want to mention something. Notice this syntax that I'm using right here. Open paren, function, so on and so forth. And then down here, I close the function, close the paren, and then immediately call the result. This is called a, what was it, independent, isolated, something. It's abbreviated IFI.
Immediately invoked anonymous function.
Immediately invoked anonymous function. The idea here is that this syntax allows me to completely isolate all access to this variable I. It restrains the scope of I so that it doesn't affect anything else anywhere in the app, and in fact is invisible to anything other than anywhere else in the app, except for its usage within this scope right here, or within this closure right here. So, a programmer writes a unit test for this service. This syntax right here, before each module demo, is one of the AngularJS hooks into the Jasmine unit testing framework. You can invoke this module and have all of the services of that module ready for use in your unit tests. So here we've got an injector that injects the counter service into this function, and we use this service to call getCount repeatedly. So we have the first call we expect to be 1, the second call we expect to be 2, the third call we expect to be 3. So that unit test passes. And she writes a second unit test for this service where the counter is expected to count to 6. It's nice to have 2 unit tests like this to prove that there's nothing special about the number 3, that it actually does count higher, for example. And this unit test passes as well. However, our programmer then put both of these unit tests together into a unit test suite. Now, in this test suite, they would run one after the other. And this is how the unit test would actually be run in a pre-submit script. For example, whenever you change some code, just before submitting it back into the repository, you could fire off a script that runs all of your unit tests en masse to make sure that you didn't break existing functionality. Or alternatively, a rolling build script would integrate new code into either a QA or production environment, and it would have and it would run these unit tests before doing so. This is how it would do them. This is how it would do that, one after the other like this. And when our programmer attempted to do this, she got a failure. Specifically, the second one, the second unit test announced that its very first run, whose output it expected to be 1, was actually 4. Now the reason is fairly straightforward if we look at what the code is doing. Remember, this function getCount is accessing a secret variable I that is getting incremented at every call. And it's the same variable I at every invocation of this service. So that means that the first 3 calls are 1, 2, and 3 as expected. The second call starts out at 4. Or the first call of the second unit test, rather. This is an example of a false positive. What it means is that the unit test suite is reporting that the code failed, even though the code is actually doing exactly what the programmer wants it to do. What's going on is that first unit test is altering the environment in a way that affects the way that the second unit test executes. Here's another example that we can't see because of horrible rendering. But what we've got here is a function that called getElemHTML. We're going to use a little bit of jQuery here. We're going to use a little bit of underscore here. Now, actually, I think just jQuery. This function is supposed to be passed an element ID, look through the DOM for an element of that ID, and then return the HTML of that element. Optionally, it can take a flag that, if specified, will create that element for you while it's looking it up, and attach it to the end of the body. In which case, it'll just return the empty HTML of the new element. Now, this function has a bug in it. Instead of creating a new element, it simply blanks out the HTML of any existing element that it happened to find. So not only does it not create an element, but it ruins whatever element it actually did find. So here's what the unit tests for this function might look like. The first unit test, getElemHTML, looks for an element with the ID of foo. And it expects the HTML for that element to be undefined because there is no element called foo on the page. The second function, the second unit test, will create an element with the ID of foo, give it the contents, just the text bar, and then add it to the document body. And then we expect getElemHTML of foo to be simply the string bar. The last unit test should get the element of the ID foo, and by the way, create it if it doesn't find it. And in this scenario, we expect it to be to return the empty HTML of the newly defined of the newly created element. Now, the programmer that wrote this arguably might not be aware of the fact that there's a bug, but all of us sitting here know that there is. That third unit test should fail. That third unit, there is no functionality in our original function for creating a new element. All there is for blanking out an existing one. And yet, when we run these 3 unit tests, they pass. Even the last one, which is exercising functionality that our code doesn't actually have. Now, to drive home this fact, you can run this last test by itself. AngularJS defines a function init, which allows Jasmine to only run that one test in isolation. And we see that when run by itself, outside the context of the unit test suite, sure enough, that function fails. Why? Well, because that second unit test is in fact adding an element with the ID of foo to the DOM. And that element is still there when the third unit test runs. So the third unit test exercises its broken functionality. It looks up the existing element that shouldn't be there. It blanks out its HTML, and it gets the empty HTML string that it expects. And I'm going to ignore these slides because that shows how it does it, but the PDF conversion here was terrible. Now, what's going on here is the second test is polluting the DOM to give the third test a false negative, meaning that it's claiming that the code works when it's actually broken. Now, false negatives are much worse than false positives. With a false positive, you at least know that something is wrong. And as you plow through the process of figuring out what that something wrong is, you eventually discover that your environment is polluted, and you can fix it accordingly. With a false negative, you're given a false sense of security, and you operate under the mistaken belief that your code actually works fine when in reality it's completely broken. Typically, you can't, with false negatives, you don't know that there's something wrong until your code hits QA or, heaven forbid, production, at which point you see something going wrong there, but you can't account for it because the fact is that it works, that you've already tested for that specific broken piece of functionality in your unit tests, and as far as you can see, there's nothing wrong. Now, common types of pollution from unit tests include pollution of the DOM, as we saw with getLMHTML, pollution of namespaces, and global variables, global isolated closure, so on and so forth, as we saw with the counter service. And in AngularJS projects in particular, they're especially vulnerable to pollution of service objects, such as the root scope. Anytime you're compiling a directive against the root scope, you risk altering the state of the root scope in ways that that might subsequently affect other unit tests. And so a dark cloud hung over the unit test land. But there was hope. Here we will explore ways to hunt down and slay unit test pollution sources without mercy. Now, one approach for detecting that in order to stop unit test pollution, you have to be aware of the fact that it's even occurring in the first place. And the most straightforward way of doing that is to choose some aspect of your environment, some global object, some, the name of some service, whatever. That thing that you choose has to affect how your functions behave, and also be affected by those functions in turn. Before each unit test, you grab a snapshot of this environment, of this aspect of your environment that you intend to monitor, or you force this aspect into some known clean state, such as by calling, let's say, body HTML with an empty string, so that it clears out all the contents of the DOM. You can do that, and then after each unit test, you compare the state of your environment's aspect against what it was before your unit test ran, and then you throw an exception if they're different. Here we have an example of how to build a pollution detector for the DOM. What we're doing here is creating an object called pollution detector that has two member functions, one called setup, one called teardown. In setup, we grab a snapshot of the outer HTML of the document body. That'll include the body tag itself along with any attributes. And we store it all as one big string. In teardown, we likewise grab a snapshot of the document outer body, and we compare it to what our snapshot was before. And then we throw an error if it was broken, if the two differ in any way. We will add pollution detector setup to run before every unit test. We'll run pollution detector teardown after every unit test. And when we do that, we find that sure enough, revisiting our getLMHTML example, we find sure enough that that our second and third unit tests are in fact polluting the DOM. What this tells us is that they might be affecting the way that every subsequent test runs, and that from the moment we see one form of DOM pollution, we shouldn't trust any other subsequent test output. So knowing that our unit tests are dirty, much like the conversion of this slide, we can add code to make each unit test clean up after itself. Here we're simply removing the new DOM element that was added at the end of every unit test. And when we do that, we get an unpolluted run. The unpolluted run shows us that sure enough, the third unit test does in fact fail. And that gives us the opportunity to alter the code of our getLMHTML function to make it exhibit the correct behavior, such that we can make our unit tests pass and live happily ever after. Here's an example of how to detect pollution on the root scope of a couple of different kinds. Now, the root scope is a big, complicated, deep object. We don't want to do deep comparison of the object, mostly because deep comparison is a very, very tricky issue. But what we can do is perform a shallow comparison of the state of the root scope object before and after each unit test is run. Here we use the underscore method clone to grab a snapshot of the topmost elements of the root scope before the unit test is run and afterwards. And likewise, we can use the underscore function is equal to do a piecemeal comparison of every object in there. If the two are different, then we know that something about the root scope has changed. And this is useful for catching child scopes that were created but never destroyed. This is useful for catching lingering event handlers and watch expressions that were never deregistered. And those are a big deal, by the way, because if you put a watch expression on the root scope, it'll keep firing at every digest cycle after that, and at best, it could very well affect everything else that your code is doing. Even if it doesn't, then chances are it'll slowly build up the number of things that your digest cycle is doing, so that you might notice that if you have a suite of hundreds or possibly thousands of unit tests, you'll find that they start getting slower and slower the later in the unit test cycle they go. And this is great for cleaning that out. And lastly, it can be used for detecting properties that are added to root scope but never removed. Now, there's another approach to decorating AngularJS services. This approach is much more complicated, but it's extremely useful for detecting not only that pollution is occurring, but exactly where that pollution is coming from. This approach involves decorating the service provider, intercepting calls to that service, and testing the call arguments against values that might be invalid for whatever reason. Such as if they're accessing global functions or services that you wish to keep clean. Here we see how something like this can be built. In this example, we're going to decorate the compile service provider. What we're going to do is inject a root scope into the compile services decoration, and we're going to alter the behavior of the compile service such that it returns to us a modified linker. This linker, before it's run, compares the scope that it's being linked against to the root scope, or run against rather, to the root scope. And if the two are the same, it throws an error. If the two are different, then it goes ahead and does whatever the heck the linker was going to do beforehand. Now, this is some rather deep Angular magic foo. So I'm going to walk through this. The provide service gives us a decorator function, which allows for us to specify the name of the service provider that we're going to be in turn decorating. That provider will then be passed as the delegate service, so that over here, what we're calling compile is actually this compile delegate over here. Now, the compile service returns a function. That function, in turn, is the linker. The compile service is intended, in other words, the compile service is a function that returns a function. The arguments to the compile service are a piece of HTML or a DOM element or a jQuery wrapper to a DOM element that will get compiled into, tested for directives and so on and so forth. What it then returns is a linker, which is itself a function that takes as an argument a scope. So what we're going to do here is we're going to tell the compile service to return a function. Within that function, we're going to take the original linker that the compile service would have returned anyway, and we're going to return from this function a new function that takes a scope. It tests this scope for equality to the root scope. If it's equal to the root scope, it throws, and if it's not, then it simply returns what the original linker would have done. Right. Here's an example of a very simple directive called foo. This directive lives in our demo module, and what this guy does is he simply takes whatever element he's declared on and replaces him, or rather adds to him a div with the contents foo, and that's all. Here's what the unit test for our foo directive looks like. We're going to inject the services compile and root scope, and in this unit test function, we create an element with this data foo attribute, which, when compiled, produces a linker, which then, when linked against the root scope, creates this, puts this element div foo inside this element div data foo. And then we expect the text of our element to just be the word foo. Now, the unit tests on that pass just fine, but there's a problem. We have now, because we have compiled against the root scope, we have introduced the possibility that we're actually modifying the root scope. And so, what we want to do is add our pollution detector to make sure that that doesn't happen. Here we use the before each module function to list the modules that are being used in our unit tests. Pollution detector, we can add pollution detector to that list of modules. And now what that means is that, to back up a little bit, is that this whole function sequence is being called. Pollution detector is the pollution detector module is being used, which means that the pollution detector module's config method is called, which means that that the root scope gets instrumented, or sorry, that the compile service gets instrumented. And so when we try to run our unit tests with the pollution detector module injected or included, it fails as we want it to. Not only does it fail, but it gives us the exact line on which the pollution is occurring. And so we can fix this, and so we know exactly where to go in order to make the unit test not pollute the root scope anymore. This modification, as you can see here, creates a child scope through a call to root scope new, and then compiles against that child scope and destroys the child scope when the unit test is done. And then the unit test passes again with an assurance of root scope cleanliness. Hooray. Now, how best to detect pollution of global variables and variables that are isolated in anonymous closures, such as inside an IFI, like we have, like I've demonstrated, for example, where'd it go? Right here, for example, RS shallow before. Remember, I said that nothing outside of this closure right here can possibly have access to this variable name right here. And because the closure is an anonymous function, there's no way to even get access to the function to the closure itself. So, how best to tell whether there's pollution occurring in situations such as this? Beats me, honestly. If any of you have brilliant ideas, this is definitely room for discussion. But something is better than nothing. And if there's some way to tell that your services, that your DOM, and that your accessible global variables are being polluted, and that your unit tests are lying to you, it's best to know than not to, because knowing, as we all know, is half the battle. And thus the saga continues, and that's all I've got for you today. Thank you. All right, we've got a question over there. Is there a microphone nearby?
I'm on my way.
Cool.
Have you run into any trouble with unit testing with Jasmine, with Angular, when you're using require.js and manually bootstrapping? Because I've had a lot of trouble just getting my unit tests to run, and wait until Angular's finished booting and for all the elements to get in before it starts hacking away at it?
You're talking primarily about dependency problems and boot up time related to that?
Well, I get issues like I can't find inject, or something about it not being able to access anything called inject.
So if you find that, so I have in fact run into this problem, can't find inject, can't find module, and the reason is that those are all included in angular-mock.js. And you want to be pulling that file in, that's where all those symbols come from.
Thanks.
Anyone else? Wow, really?
One more over here.
How do you test asynchronous functions with Jasmine?
So, very good question. Nothing I showed here was involved asynchronous function testing. The reason is that Jasmine actually provides an extensive mocking system, likewise in Angular mocks.js and Angular resources, that allows for that basically takes all of Angular's own HTTP calls and XHR calls and is able to provide wrappers for them to then return fake data. The nice thing about unit testing asynchronous calls is that AngularJS itself is where all those asynchronous calls come from. So that's a bit outside the scope of this talk, but the fact is that AngularJS has an excellent XHR testing framework.
So a quick note on that. If you look at the Angular documentations for both the HTTP service and the timeout service, the mocks for those that are used in tests both have a function called flush that you could use to trigger the completion of that asynchronous thing.
This is just a general question about how much of your time do you say you spend writing unit tests with Angular?
I'm very glad you asked that. I would different times vary. Different developers have different takes on this. My own personal opinion of my own personal time is about 50-50. Like everything that I write in functionality, I have a test for in somewhere in the unit test suite. Now, for different problems, it varies. Some very complicated piece of code can require very little time to write, but have a lot of subtleties that require a lot of time to test through, or vice versa. You could ultimately have a very long piece of code that ultimately is designed to do one very simple thing. So I would personally estimate 50-50. It can vary greatly from developer to developer and from project to project. One key thing, the reason I'm glad you brought this question up is because most managers or most organizations in general that I have seen that are resistant to unit testing or the adoption of a regular unit testing process cite the developer costs, specifically in terms of developer time, of the maintenance of the unit test suite as the key argument against immediate adoption of unit tests. I've never seen anybody flat out say that it's a bad idea, but I have seen organizations say, we'll get around to doing unit tests eventually. The trade-off is against regression bugs. And so what you want to do is calculate how much time your organization spends fixing regression bugs and unbreaking things that subsequent changes have broken. And when you compare that time against the time spent maintaining a unit test suite, it's very rare that the decision to not maintain the unit test suite wins. My own typical experience is that maintaining regression bugs takes anywhere from 3 times to 10 times the amount of time that it takes to develop the code that broke the software in the first place. So it's different projects have different sensitivities to such things. Your mileage may vary, but usually unit testing is the way to go. We have questions over here.
How do you feel the importance of unit tests? Does it get diminished when you start to do end-to-end testing?
In no way. I'm actually I'm glad about that question too. End-to-end testing is a sort of more big picture set of tests, like for example, an end-to-end test for a web app could involve let's say, a Selenium WebDriver going through the act of actually simulating clicks on the user interface and triggering behavior that way. Both are extremely valuable for an organization. The reason that end-to-end testing does not diminish unit testing is that importance is that when end-to-end testing reveals that there's something broken, the unit test can enable you to zero in on exactly what that broken thing is. In other words, end-to-end testing by definition involves the interoperation of many different components, and somewhere one or more of those components broke its contract to the other one, or two components didn't agree with what one's output should be relative to the other. And unit testing can help you zero in on which one is missing its expectations. And one more?
I'm just curious, do you take a write test first approach as TDD advocates, or do you have a different approach?
I knew this one would come up.
I'm not trying to start any trouble. I'm just curious what your approach is.
It's been known to be a frequent source of trouble. The question is whether or not is basically the frequency of test-driven development. What test-driven development is, it basically means when you have a set of specifications for what your program is supposed to do, the idea is to first write the unit tests for that program before it's doing anything, before you write any piece of functional code, fully knowing that the unit tests are supposed to break, and then developing until your unit tests pass. The old joke with TDD is that you start with an empty main function and then debug. I love TDD in theory, and if I had perfect self-discipline, I would be TDDing all the time. In practice, what I find is that you seldom don't even know what questions to ask of the piece of software until you've already embarked on the process of developing it. So what I frequently do is, as I develop any particular piece of functionality on a program, I will have sort of I will manually execute the things that I ultimately will want my unit tests to do, and test my development against my own manual tests. Then once usually with JavaScript, it often involves just bringing up a browser console window and just typing the commands that I will ultimately put into unit tests. When my own manual tests work, I then put those into a set of unit tests, and then go on to add more functionality to my program, and prevent regression. So in short, do I do TDD? Not really. It's almost like I do something in between, which is sort of regression testing as you go. But it's, like I said, your mileage may vary. I'm afraid that that's all the time that we have for questions today. Thank you guys for coming.